The main support beam gave way right there.
We need to check for further instability before we move closer.
Look at the stress fracture on that main support.
It's barely holding. We need to secure the perimeter before we move anything.
Agreed. The whole thing could shift. The rebar here is completely compromised. Look at the shear fracture on this section.
And the displacement on the far side suggests the entire upper structure is unstable. Be careful with that section, it looks unstable. Okay, moving this one now. Look at the intake manifold there. It's remarkably preserved beneath the strut. We should log the coordinates. Logging that now. Structural integrity looks good on the sensor.
It's definitely the Draken. Look at the nose.
Incredible. The corrosion is heavy here.
Okay, stop there. Angle the arm slightly to the left. Copy that, moving left.
Be careful near the wing root. I see it. The concrete here is loose. Use the soft brush on that section.
Confirm sequence Charlie on the checklist.
Sequence Charlie confirmed. Stand 4 engaging hydraulics. Pressure nominal.
We need to secure this forward lifting point first. The structure here is compromised. Roger that. I've got the strap positioned, just checking the tension.
Okay, lift on my count. Ready? Pull. It's moving. Get the pry bar under it.
The structural integrity around the main spar seems compromised. The gantries are holding steady, but we need to monitor the stress points during the lift.
All right, steady as she goes. We've only got a few inches of clearance on that port wing.
Look at the stress cracks here near the landing gear. Yes, the corrosion is worse than expected on the double delta. I've logged the rivet condition on the tail.
Look at the corrosion right here by the rivet. See the pitting? Yes, the micrometer shows significant thinning. We need to document this extensively.
Look at the corrosion right here by the joint. Yeah, I see it. The delta wing leading edge seems structurally sound though. Readings confirm that.
Check the transparency on this section. Lots of micro cracks near the hinge.
Agreed. We need to document the deterioration.
The strut attachment point shows significant stress factoring. See the reading here.
Agreed. I'm noting the deterioration level on the main gear assembly now.
Look at the corrosion right there at the 5 o'clock position. We need to document this immediately. Got it. Logging the coordinates now.
We need to document this structural wear near the landing gear carefully.
I'm marking this section as severe corrosion on the inspection sheet.
We follow the sequence here for the wing removal. Pay close attention to the hydraulics. Got it. I'll monitor the pressure readings, and I'll double check the fuselage mounts.
A little more to the right, keep it steady. Got it. Securing the locking mechanism now. All right, engage the hoist slowly. Keep the tension steady. Copy that. Lifting now. Strap secured. Let's go up slowly.
Copy that. Coming over the stand now, clear on your side?
Yes, bring it down gently.
See that stress fracture near the mount point? I see it. Make sure you get a picture before we touch it.
This actuator goes right here next to the fuel control unit.
Okay, position confirmed on the schematic.
The reading here is slightly off the baseline. We need to verify the calibration.
Okay, I'll make a note of that deviation in the log.
Look at the extent of the corrosion here on the main spar.
Yeah, that's significant.
I've made a note for the report. The readout is 45.2 millimeters. Confirmed. The documentation specifies 45.2, maybe a slight tolerance here. Check the frame joint tolerance on page 3. Make sure the curvature matches exactly here. Looks good on this end. Alignment is spot on, we can secure it. How does the seam look after the polish? Smooth. The geometry is perfect.
Check the clearance on that turbine blade. It looks slightly off spec.
Yeah, I see the oxidation. Let's check the manual for the tolerance.
All right, the compressor casing is clear. Let's move on to the combustion chambers next. Look at the leading edge here. That pitting exceeds the service limit.
Confirmed. Recording the measurement now.
We need to ensure the retraction mechanism is completely free of debris before we test the hydraulics. Agreed. Let's hit it with the high-pressure air. All right, I'm torquing the B-nut now. Specs are 75 foot-pounds.
Reads good, nice and secure. Reading 45 Newton meters here. All right.
Matches the spec sheet.
We are clear on the forward mounts.
Fuel lines are clear and checked against the manual. Confirmed. Torque settings are good on the mounts. All right, green light for installation. Let's move it slowly.
Reading 45 Newton meters here. All right.
Matches the spec sheet.
We are clear on the forward mounts.
Check the tension on that linkage, please. Reading steady at 50 Newton meters. Movement is smooth.
All right, I've secured the last bundle.
Let's check the continuity on the main bus. Looks good.
Just a few more millimeters down. Copy? It's aligning now. I have the clamps engaged.
Check the voltage on bus 1.
Reading stable at 27 volts. Flap indicator seems calibrated. Torquing this mount to the specified setting now.
Confirmed alignment on the fuel line. Pressure looks good. Okay, bring it up slowly on the jack. Copy that. Watching the pressure.
The alignment readings look solid here.
Yep.
Yes, the deviation is well within tolerance. All right, let's move to the tail section.
Check the alignment on this panel here. Looks good, tolerances are within spec, the finish is excellent.
Confirm the hydraulics are fully pressurized. Elevon deflection reads positive 30.
Acknowledged, logging the response time now. Moving to the tail. Connections look solid here. How are the readings on the tablet?
All green, Inge. Final panel secured.
Keep it coming slow on the left. Power at 5%. Clear on this side, Chief.
Steady now, just a few more feet. Clear on this side, looking good.